Hello, class 12th physics, chapter atoms. So, we'll begin with different atomic models. So, we have three models, major three models. Thompson's model, Rutherford's model, and Bohr's model. Right now, I'm not going to discuss that scattering experiment here. I'm just drawing the conclusion what Thompson model says, and Rutherford model says, and Bohr's model says. So according to Thompson, atom is a rigid positively charged sphere in which electrons are embedded, like this. If this is a positive sphere, this is a positive sphere, and there are electrons inside it, embedded in it randomly. So in order to counterbalance its positive charge, so if let us suppose in this atom I have made 7 electrons, so let us suppose it has 7 unit positive charge, so that is why it has 7 electrons in order to counterbalance that positive charge. So this was the simple Thompson's model, but there were some problems. Actually, to be called an atomic model, you need to qualify many things like neutrality of atom should be explained. So yeah, it is explained here. Atom is neutral here. Arrangement of electron, because till then electrons were discovered, and that's too discovered by Thomson. So of course, arrangement of electron he has proposed, and one major most important part was origin of spectra. So spectrum, as we know, light emitted by atom under specific conditions is called its spectrum. So it also explained that means when this atom is excited and it releases electron, so energy releases. But still there were some problem, like why there are so many spectrum lines in hydrogen spectrum. So there were some problem with Thomson's model. We will discuss about them later. I don't know, I don't have any solid evidences, but people say that Rutherford was the student of Thomson. You can Google it and you can find out whether it is true or not. So Rutherford hypothetically, just concept wise, just theoretically, drawn a conclusion that if we bombard alpha particle to an atom, so it will not produce that result which are expected in Thomson's model. What I want to say, we'll discuss about that experiment later. Right now I want to tell you what were the expectation and what was the reality. Actually, according to Thomson, if he take a thin sheet of metal, so according to Thomson, this is something what the arrangement of atoms there. perfectly rigid. And if alpha particle would be going there, so they will, all of the alpha particle will come back. There's no chance for those highly energetic alpha particle to penetrate this. However, maybe few could come out. So it was expected that 99% would come back and 1% would penetrate, scatter this way. So that was expectation. If Thompson's model is valid, but what happened when that alpha scattering experiment, which we are going to discuss later on, that happened, it drew a dramatic result. Right now I'm not drawing atoms here. So what happened, if these are the alpha particle, so very few bounced back, and rest of others went straight, and so almost all the alpha particles penetrated, scattered without any deviation. So reality was just reversed. 1% here and 99% here. How is it possible? So it is not something like this, that atoms are of this shape. Then what else is there? So then it was believed that atom, most of the part of atom is empty. And in that empty region, it was believed that there is electron. But how? How can be electron there? This is positive, this is negative electron. How can it be there? Because it will be pulled toward the nucleus, and that's all. Atom will not exist. So to explain this, Rutherford came up with that solar system model, that it is possible that it is these electrons are bounded with this positive charge region by electrostatic force, and that electrostatic force gives it centripetal force. So it is something like if an electron is just passing by, and with the orbital would be orbital velocity, and it get trapped, and now it is orbiting around the this positively charged region. This positively charged region should be very small, so he called it nucleus. And this is how, if there are so many electrons, so he assigned different orbits for them without any evidences. But yeah, of course, he gave this idea that atom is not that a solid sphere in which electrons are embedded, but it must be very small. It must have a very small region of positive charge and entire mass, and electrons revolve around the nucleus. It was Rutherford's model. One more limitation is there in Thompson's model. It was unable to explain alpha scattering experiment. Well, once again I repeat, I will come back to alpha scattering experiment later on. So here Rutherford's atomic model states that, so in Rutherford's model, entire positive charge and mass of an electron is confined in a very small region called nucleus. एक बहुत ही छोटा रीजन होगा जिसमें सारा का सारा पॉजिटिव चार्ज और सारा का सारा मास होगा एटम का, और उसे हम न्यूक्लियस का नाम दिया. रदरफोर्ड के लिए कहा जाता है कि डिस्कवर्ड प्रोटॉन, नो, ही डिस्कवर्ड न्यूक्लियस. एक्चुअली उसके बाद ये बिलीव किया कि देयर इज एन एलिमेंट्री पार्टिकल कॉल्ड प्रोटॉन विच आर देयर. तो इनडायरेक्टली ही डिस्कवर्ड प्रोटॉन, but he discovered actually this nucleus. Okay, next, electron revolve around the nucleus. For that, centripetal force is provided by electrostatic force between nucleus and electron. Yeah, of course, as I told you before कि अगर वो static रहेगा, it will fall into the nucleus. So in order to understand how it is stable, so it must be rotating around, revolving around the nucleus, like planets revolve around the sun. And third one most of the time is not seen in the books, but yeah, of course it is there, in order to explain origin of a spectrum. So electron undergoes centripetal acceleration. If it is revolving around the nucleus, so it experiences centripetal force, and if there is force, there is acceleration, there is centripetal acceleration. And we know in electromagnetic theory that an accelerating electron emits energy, radiates energy, electromagnetic waves. So this is what he explained to answer the origin of a spectrum, reason behind origin of spectrum. So now let's move to Bohr's model. Actually, there were some problem with the Rutherford model. I will list down those limitations later on, but there were some limitation of Rutherford's model, like he was unable to explain arrangement of electrons. Why in different orbits electron will revolve? Why not all the electron in same orbit? And there were some other problems, like if it radiates energy, then why don't it loses energy and falls into the nucleus? So to explain these, there was Bohr's model. And once again, I'm not sure, I have heard the stories. So I heard that Bohr was Rutherford's friend, and often he visit Rutherford. And guess what? These three names, what you are seeing in this paper, all of them won Nobel Prize. So very lucky sheet it is. All right, now Bohr's model. Okay, Bohr's model. While orbiting around the nucleus, electrons do not radiate energy. So these are called stationary orbits or non-radiating orbits. So he clearly explains this. Rutherford's model. Actually, he carry forward from Rutherford's model that entire mass and charge of atom confined in very small region and electron revolve around the nucleus. He agreed with this, and he resolved this third part with this first statement, while orbiting around a nucleus, electrons do not radiate energy. That's all. So next thing which Rutherford could not explain was arrangement of electrons. So electron can revolve only in those orbits in which angular momentum is integral multiple of h by 2, where h is Planck's constant. So we can write its expression also, like mvr is momentum is equal to nh upon 2 pi. In my earlier video it was also explained very well. Here I am just listing down it. And the third postulate, or its statement of its model, when an excited electron, means if it has jumped to higher energy level, returns to ground state, it radiates photon of energy equal to energy difference between the energy levels. So E equal to h nu, just in order to explain you which energy it is electromagnetic energy radiated from during that transition, is equal to E2 minus E1, difference between two energy levels. So this is what the three atomic models are all about. Now let's see their limitations. So limitation of Thompson's model: it could not explain electron arrangement in an atom, could not explain many lines found in hydrogen spectrum. If in hydrogen spectrum, if we follow Thompson's model, there should be an electron, single electron. So if it will emit energy, it should give a single line in the spectrum, but we found many lines in hydrogen spectrum, so it could not explain that. And most importantly, it could not explain alpha scattering experiment. Now what are the limitations of Rutherford model? So limitation of Rutherford model: it could not explain electron arrangement. Once again, same problem. Could not explain complex spectrum. Yeah, there were some I told about some hydrogen line. Of course, it gives some idea that electron is revolving, so different frequency it can emit of that energy. But some complex atom, it was unable to explain their spectrum, because they have some different looks other than expected. So and most importantly, that if electron undergoes centripetal acceleration, it will lose energy by radiating electromagnetic waves. So how is the atom stable? So it was unable to explain that. So that is why Bohr's model was accepted, but there were some limitation of Bohr's model also. So here are Bohr's limitation. It is applicable for simple atom like hydrogen, singly ionized helium, doubly ionized lithium, and not for not generically applicable for all atoms. It is unable to explain fine structure of atom. It has easily explained hydrogen spectrum and some complex spectrum also, but unable to explain fine structure. So it is a little bit beyond from your syllabus, so I am deviating from this also. I'm not going into it. Just this thing is enough for you. Next, it gives no information about shape of orbit, while elliptical orbit are possible. Another concept is there about shape of orbits. So now see, shape of orbit, mathematically it is proven that if electron revolve around the nucleus, Uh, and for rotational mode, that it revolves around the nucleus and it requires some centripetal force, and for that force electrostatic force is there. So electrostatic force depends upon square of the distance inversely according to Coulomb's law. And mathematically for that kind of forces, the possible orbits could be elliptical also. Other than circular, it could be elliptical. That comes mathematically. That is some higher order mathematics. We are not going into it. So if elliptical orbits are possible, then Bohr's model is unable to explain um, those elliptical orbit possibility of those elliptical orbits. And I'm reducing this statement. It could not explain uncertainty effect on orbits. Um, this is again little bit higher level thing, like electron which revolves around the nucleus at a very high speed, about 10 to the power 7 meter per second, which is near about speed of light. So and it is very small particle also. So according to uncertainty principle, we can certainly uh, find the position and momentum of such particle. So if we are unable to find position of such particle, how can we say that this is the orbit of electron? It should not be like this. It should be like this, that it is uncertain. So it does not explain that part. I mean, it is not mentioned that these orbits are not certainly defined. So however, Bohr's model says that these orbits are certain. So these are some of the limitations of these models. Now the major thing will start with the alpha scattering experiment, on the basis of which Rutherford model stands. So here we have Rutherford's alpha scattering experiment, or Giger and Marsden alpha scattering experiment. Well, these two fellows, Giger and Marsden, we don't know about them. If you could remember, in the beginning of this lecture, I told you that theoretically, Rutherford came out with those results about alpha scattering experiment. But again, um, I'm not sure about this. I have heard, I have gone through some internet blogs and came to know that Rutherford unable to perform those experiments. However, Giger and Marsden, who were the student of Rutherford, they performed that experiment and found it. They are the results of experiment are in good agreement with the expected results from Rutherford, which he derived theoretically. So, what was that experiment all about? So, first, I will draw the setup of that experiment, and you people should also try to draw it along with me. So, this is a lead box in which some radioactive material is filled. In the books, radium is written, but it is, I guess, polonium was there. But anyway, it was some radioactive material. Radio active material. This is the lead box. With a pinhole, so that a fine beam of alpha particle can be emerged from it. Then there was a gold foil. Why gold? Actually, gold is highly malleable. First reason. Second reason, gold, the mass number of gold is higher, so it is expected that its size of its atom would be larger in order to get good impact with those alpha particles. See, it was a foil of few microns, thickness of few microns. Microns 10 to the power minus 6 meter thick. Gold foil. So I generally say a story about it, that Rutherford put this here. Actually, not Rutherford, but Giger and Marsden put it here, and they were expecting that all the alpha particle will bounce back. So they asked their servant to stand here, and they started experiment. And when they came on other side, their servant turned pale, pale yellowish colored. So पीला पड़ गया. क्यों? सारा रेडिएशन तो इधर चला गया. उन्हें लग रहा था कि सारा रेडिएशन इधर आ जाएगा. सो देयर वाज देयर सर्वेंट, और वो पीला पड़ गया. तो उन्होंने कहा भाई ये कैसे हो गया, सारे अल्फा पार्टिकल तो इधर चले गए, इधर तो कुछ भी नहीं आया. तो दैट इज जस्ट अ स्टोरी फॉर जोक्स, टू क्रैक सम जोक्स. एनीवे, तो एक्सपेक्ट करो, मतलब आप ये सोच के चल रहे हो कि सारे अल्फा पार्टिकल उल्टा जाएंगे, इधर जाएंगे, तो इधर आप कोई सेफ्टी नहीं रखोगे. बट व्हेन यू फाउंड दैट ऑल द अल्फा पार्टिकल आर ऑब्जर्व्ड हियर, तो ये बिल्कुल उल्टा हो गया. इट इज समथिंग लाइक वी आर थ्रोइंग द बॉल ऑन टू द वॉल, and instead of bouncing back, it is penetrating the wall and going to other side. So in order to catch those, first they put some screen here, but sorry, they put some screen here, this side, because it was expected that all the particle will bounce in this direction. But when very few particle were found, they put it here, still very less amount of particles. So then they enclosed entire unit with a photographic film, photosensitive, like this. And it was some photosensitive screen, so that these scattered alpha particle can be tracked. So what have they observed? There is a shower of alpha particles, and they observed that maximum alpha particle passed without deviation or a slight deviation. Very few in number deviated at larger angles, and negligible bounced back. So symbolically, Okay, this screen was of zinc sulfide. Okay, so this is alpha particle stream. All right, so a symbolic diagram for this experiment was like this. There are atoms and still particles, alpha particles, are passing either straight or with some deviation, and very few are returning back. Or it can also be represented in terms of a single atom. Okay, we will discuss about it later. So what are the highlights of this experiment? So I will write down the experiment and its results. So before going into the observation, I would like to say that okay, choices of first gold foil, as I told you, it is highly malleable and having greater mass number. Second thing, choice of alpha particle, because from radioactive sources we can have very large, highly energetic alpha particles, so not required for actually its acceleration is not required. We have some accelerator which can speed up charged particle, but they are obtained from a natural source. So, and why alpha particle? Because it has, alpha particle means 2He4. Alpha particle contains 2 protons and 2 neutrons. So it is a massive particle, little bit from other particle than proton, neutron, or beta rays, beta particles. So they are bit heavier in radioactive reactions. The particle which are emitted, it is heavier than them, and it carries charge, 2-unit charge, that of proton, and it has 4-unit mass. So that is why we can say it carries high momentum and it has higher charge than other particles in nuclear reactions. So okay, so now okay, so these are the observation. 99% particle scattered, undeviated. I'm saying scattered, passed. I have to say passed, undeviated. They had gone straight, and negligible alpha particle bounced back, and slight deviation was also observed, which passed in a straight direction. Slight deviation observed, as if there was some repulsion due to positive charge. So there is a graph also, and very important one as the point of view, in the point of view of exams. So this is the graph between number of scattered alpha particles, number of scattered alpha particles. And here we have theta, that is angle of scattering. Angle of scattering, the angle through which that particle get deviated. So there is 0. I am drawing a schematic graph, but I am putting some values in order to here I just jumped the values. So I'm doing this, putting some values. You need not to put the values. I'm putting it to give you a general idea about it. So here 10 to the power 1 particle, 10 to the power 3 particle, 10 to the power 7 particle. So let us suppose with these values I'm drawing this graph of scattered particle. So actually maximum particle falls in this region, uh, making angle less than 20. So they enter here, and this was the gold foil. So either they penetrated it or they get deviated at smaller angles, maximum of them. So graph goes like this. I'm not touching it from the coordinate. Oh, 10 to the power 1 is quite less, so I'm putting 10 to the power 2. Otherwise it will look like 1 of the million. So graph is something like this. We can say it is a kind of inverse proportion graph, but not exactly that, but it falls like this. And for 180 repulsion, I'm just ending it here. So we can assume that reaching this point, there will be very less, negligible amount of those particles. All right. So this graph is also called graph between angle of scattering as function of number of scattered particles. So on the basis of this, the Rutherford atomic model was established. That explanation I'm writing here, saving paper. So 99% alpha particle scattered undeviated. It explains that most of the part of atom is empty. In which electron revolves. Second, negligible, bounced back. It explains that most of the mass of atom is confined in a small region. And third, they get deviated, they experience some repulsion, so all the positive charge is there in a small region. Which is later called nucleus. So this was all of it. Uh, on the basis of this, Rutherford atomic model was formed, and in the beginning, I have mentioned that Rutherford's model. Once again, we will have a look on that. So I'm not reading it once again, but I'm just reminding you this is there. So is this only the thing Rutherford did? Actually, he estimated, he gave an idea to estimate the size of nucleus. So this is the topic: estimation of size of nucleus, or distance of closest approach. How close we can go to nucleus. So here we have a nucleus, and now we will not just think about gold nucleus. So this is a nucleus. Charge on nucleus is Ze. Z is atomic number, that is number of protons, and here alpha particle is coming, and let us suppose it is coming along the line of the center of that nucleus. So it is going for a head-on collision. So the direction in which it is coming, it will return back in the same direction. So at the moment it is in the closest approach, let us suppose this distance is r0. Actually it is not that much big, but yeah, it is appreciably bigger than the radius of nucleus. So this is alpha particle having 2e charge. So at closest approach, kinetic energy of alpha particle is equal to potential energy of alpha and nucleus system. So that is for kinetic energy I am writing Ke subscript alpha is equal to potential energy. Yeah, now return back to that electrostatics. So there is an expression for potential energy that is K 1 upon 4 pi epsilon naught Q1 Q2 upon R. So we just replace it with small k. So same thing I'm going to do here. K Q alpha Q nucleus upon R, this distance of closest approach. And that's all we have to explain. What is K? K is 1 upon 4 pi epsilon naught, and R naught is distance of closest approach. And from here, kinetic energy alpha is equal to K, it is 2E, and it is Ze upon R naught. So R naught, distance of closest approach, is equal to K 2Ze square upon kinetic energy of alpha particle. So if we talk about radius of nucleus, so radius of nucleus is less than r naught. I know whether this question came in board or not, but a question came that an alpha particle. Okay, let's um, consider that question here. An alpha particle question. Of kinetic energy 5 mega electron volt goes a closest to a closest approach with an atom of Z equal to, let us suppose 100, looks good, 100. Find radius of nucleus. Well, in CBSE, such kind of ambiguous question will not be asked. But similar kind of confusion they can create. So what you have to do, if in fact, if you don't remember this formula, just put this condition, kinetic energy equal to potential energy. Yes, I'm going through this way. I'm not directly applying this. Okay, let us suppose I don't remember this formula. So kinetic energy is equal to potential energy, that is K Q alpha Q of that nucleus and upon R naught. So there's nothing complicated about this. 2E ZE upon KE. So there's nothing which you need to memorize. That's all. Formula formed. So R naught is equal to K 1 upon 4 pi epsilon naught, that is 9 into 10 to the power 9 to ZE square. Z is Z and C my trick, E square and upon it is in mega electron volt. Oh sorry, it is 100. Z is 100. So and E square, of course, I need to put the value 1.6 into 10 to the power minus 19 square and upon kinetic energy, which is 5 mega electron volt. We need to convert this 5 mega 10 to the power 6 electron volt 1.6 into 10 to the power minus 19. Now it is joule. So this will be get cancelled with 1 power and what else, 18 1.6 upon 5. I'm doing an approximate calculation which I used to do. You people have to do this calculation, but I'm doing it in shortcut. 0.3 to the 0.6, 5.4. My answer can be wrong, so I'm not going with that 4. 5. Alright, 5.4, no problem. There will be some error in second place, so not a big problem. 5.4. Oh, too much cutting is there, but okay, that is accepted. Neatness should be there. 10 to the power 9 minus 19, that is minus 10, and 6 will go up minus 10 minus 16. Well, practically this result is invalid because nucleus has size of 10 to the power minus 15, but as you know, I have taken these value randomly, so such kind of things can happen, and according to this, but still it is not the radius of nucleus, so radius of nucleus will be less than 5.4 into 10 to the power minus 16 meter. It is just an hypothetical question, so don't take it seriously, but yeah, take the process seriously. So this is all about atomic models, and these are the different ways through which we have to go. Okay, one more thing, but that is only qualitative, not quantitative. That is only qualitative discussion, and that is also important because that concept, that topic is removed from the syllabus, but related question comes, and once again we can't challenge them because they say that if a student knows these atomic model and about theory behind them, they should answer that part also. So that term is called impact parameter. Earlier it was in the syllabus with a formula, but now it is removed. Now what is impact parameter? The perpendicular distance between the initial trajectory, initial path of alpha particle the perpendicular initial path of alpha particle from the target nucleus is called impact parameter. What does it mean? Let us suppose this is a nucleus and there is an alpha particle going like this. Because of repulsion it will go that way. So this is the impact parameter. This perpendicular distance is called impact parameter. So most of the time they used to say that impact parameter, if impact parameter is less, then what will happen? So if impact parameter is less, then there will be larger deviation. And if impact parameter is smaller, larger, then there will be very negligible deviation or no deviation. If impact parameter is 0, then what? I am ending this lecture with this question. If impact parameter is 0, then what? Write your answer in the comment and see you in the next lecture. Bye.